Well, greetings, mathletes, and welcome back. Today's lecture is going to be fairly straightforward. We have one set of identities to look at, and then we're just going to look at a few of the different ways that those identities are used. The identities we're interested in today are actually the sum and difference formulas for sine and cosine. And like I said, they're relatively straightforward once you have the formula and how it works. It's just you can just be creative about how to use it. So we're going to take a look at some of that today. So let's go ahead and get started here. Okay, so what we are looking at are the sum and difference. Oh, try this again. There we go. Sum and difference formulas. Oh, my handwriting's bad today. So we have sum and difference formulas for sine and cosine, basically. So they look like this. Cosine, and this is what I mean by sum and difference. If we can look at an angle as the sum of two different angles, cosine alpha plus beta, right? We can separate that out into alpha and beta by looking at cosine alpha times cosine beta minus sine alpha sine beta. Okay. Right. It's just a way of converting things. Sometimes you can, if it's an angle you don't know the cosine for, you can't find it from the unit circle. If you can break it up into two angles that you know the sine and cosine for, you can plug it into this formula. And then likewise for sine, right? Sine of alpha plus beta ends up being sine alpha cosine beta plus cosine alpha sine beta, right? Okay, so those are two ways to split this up. Now, I know what you're thinking. I said sum and difference formulas, and all I've given you are sum formulas. And it turns out that what you do to find the difference formulas, there's two things that that you need to pay attention to. One, basically, if we're looking at something like, alpha minus beta, you can rewrite that as alpha plus negative beta. So if you substitute negative beta for positive beta, right? So I just change this to a minus. It's the same thing, but I'm just putting a negative angle. You can still follow the same formula. The thing you have to remember that changes everything is that cosine of negative beta, right? If you're taking cosine of a negative number, that's going to be the same as the cosine of positive beta. And the sine of negative beta, is equal to the negative sine of beta. So if I have a negative angle with sine, it changes the sign of the term, right? If I have a negative angle with cosine, I can just make the angle positive. So these two things, along with this substitution, will give you the following formulas. Let me back that up, get those off of there, and I'll put it in a different color. Cosine alpha minus beta is going to be cosine alpha cosine beta plus sine alpha sine beta, right? So these two guys go together. Notice the differences. You can use these guys down here to verify it yourself. I think it's actually a good exercise for you to go through and try to verify that these two formulas are actually the same formula, even though you're given them as two formulas. Then down here, right, if we make beta negative, you'll notice this, if I make this beta negative, I can just turn it back to positive. It doesn't change the first term, but if I make this beta negative, it's going to change this. Using this, it's going to change the sign of sine. I was trying to find a better way to say that. But basically you end up with this. sine of alpha minus beta is equal to sine alpha cosine beta minus cosine alpha sine beta. Right? And so this is the other pair of things that you need to know. Okay, so as long as you can handle those things, those are the main ones we're going to focus on today, you're going to be good. So let's take a look at how this actually works now. Okay, so hopefully you have those jotted down. Also, it's on that formula sheet I gave you in a previous lecture. So be aware of that. Let me go ahead and get these guys off of here, and we're going to take a look at this. So, again, this is one of those things where you're trying to find the sine or the cosine of an angle that isn't a typical unit circle angle. You can actually do something with it. So let's go ahead and look at cosine of 75 degrees. Now, if you look at your unit circle, the things that we do know are, we know 0, 30, 45, 60, and 90, right? Those are the ones from the unit circle that fit into this category. In fact, all of those are first quadrant. But if you're creative about it, you can look at this as cosine of 30 degrees plus 45 degrees. Right? If I look at it that way, here's my alpha and here's my beta. Right? This is my alpha plus beta. So it's just a matter of using the formula now. And I know that cosine alpha plus beta, by the way, it's a really good idea just to jot down the formula every time you use it. It just really helps you remember it. Right? So we know that's alpha and beta, and we know that cosine alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. Right? So now that we know alpha and beta, it's just a matter of plugging things in. So I can say that cosine 75 is equal to cosine 30 degrees times cosine 45 degrees minus sine of 30 degrees times sine of 45 degrees. Right? And then we can just look up the values for these things. You should have a sense of what they are. But cosine 30 is root 3 over 2 times cosine 45 is root 2 over 2 minus sine 30 is 1/2 and sine 45 is root 2 over 2. And so we just need to simplify this expression now. So root 3 times root 2 is root 6 over 4 minus, and then over here I have root 2 over 4. And since those have a common denominator, this is now root 6 minus root 2 over 4. Right? And that's pretty much how it works when they're numbers. You play around with all the things you know and then go from there. Now you notice, now that we've worked this out, cosine 75 is a value we know. That means if you have another angle splitting thing, you can use cosine 75 in a sum or difference formula as alpha or beta now, because you know the answer. Okay, so that's the first way these things are used. Other times they're used to verify other identities or to create other identities. So let's take a look at one of those. Where did I put it? There we go. Let's go ahead and delete that. Let's say we are trying to demonstrate, we want to show that sine of x plus pi over 2 is equal to cosine x. Well, we have a clear sum here, right? And by the way, especially those of you going to calculus, this is going to be a very useful thing to do when you have something that's offset like this, because what this is a phase shift, right? And so this is a way of handling phase shifts algebraically. Okay, so that means that x is alpha and pi over 2 is beta. Okay, so now we just need to use the formula. So the formula says that sine alpha plus beta is equal to sine alpha cosine beta plus cosine alpha sine beta. So let's plug everything in. So this would be sine x. Is that right? Yeah, okay. Sine x, yeah, we're okay, times cosine pi over 2 plus cosine x plus sine pi over 2, or times sine pi over 2. Okay, well, let's see. Sine x is just sine x. I don't have a value there, so it stays sine x. But cosine x is, or cosine pi over 2 is 0. So this is now sine x times 0 plus, let's see, cosine x, I'm just going to leave here. Sine pi over 2 is 1. So the 0 kills this, and the 1 just reinforces it. It just keeps it there. So now we have cosine x. And so we've just demonstrated that sine is a phase shift of pi over 2 off of cosine. And you can actually see that from the graph, that if you shift the graph by pi over 2, you end up with the other function. Okay, so that's another way this is used. And, we just as easily could have done this with a difference to see what it looks like, right? If I subtracted this, I believe, if I'm not mistaken, this comes out to negative cosine if I subtract it instead. So, there's lots of little things that you can tease out of this. Okay, so let's go ahead and look at the next one here. Now, the next one is kind of interesting. In fact, it's one of those ones where it's kind of clever, but it's not a crazy cleverness that you can't come across yourself. So what I would like to do is have you guys look at these two. I'm going to give you two this time and see if you can demonstrate that these are true statements. Sine of 2 times alpha is equal to 2 sine alpha cosine alpha. And the other one is cosine 2 alpha is equal to cosine squared alpha minus sine squared alpha. And I think if you can figure one out, the other one will follow pretty quickly. But go ahead and pause the video here so you can work on it. And then we'll work it out together and see how that goes. Okay, so go ahead and pause it here. Okay, so let's see how we did here. The trick with both of these is the same thing. It's the fact that 2 alpha is equal to alpha plus alpha. So that means we can rewrite this as sine alpha plus alpha. There's absolutely no reason that alpha and beta can't be the same value, right, when you're looking at this. So if that's the case, we just need to use the formula. And the formula for alpha plus alpha would be sine alpha cosine alpha plus sine alpha. Oh, I'm going to run out of room if I do this. Let me just scoot this over. So it'd be sine alpha cosine alpha plus sine alpha cosine alpha. And that's the same value twice. So what that ends up being is 2 sine alpha cosine alpha. And, excuse me. And this identity is actually one that's used quite a bit. When you have an angle that's too big and you need to bring it down to size, this is a way of splitting the angle in half, because if 2 alpha was 60 degrees, then each of these would be 30 degrees, right? And so those are things you can handle still. Now, over here on this side, now that we've verified this one, it's pretty much the same thing as far as looking at this as cosine of alpha plus alpha, right? As soon as you do that, all you have to do is plug things in. And so we end up with from the formula, cosine alpha times cosine alpha minus sine alpha times sine alpha. Ooh, almost ran out of room here. Cosine times cosine is cosine squared. And just a reminder, when I write this, what it means is this, right? It's just a shorthand. So just be aware of that. That causes confusion sometimes. So cosine squared alpha minus sine squared alpha, which is what we were trying to prove. And if you remember, we actually saw this in this particular thing in a previous identity that we derived. If I substituted the 1 minus cosine alpha, we could actually get cosine 2 alpha to also equal to 2 cosine squared alpha minus 1. Or, yeah, it's minus 1. Try to remember that one. But in any case, you can see how we're using one formula to verify or come up with another formula. And this is really, really common. And this has to do with the consistency of mathematics. That if you can come up with something one way, you should be able to come up with it another way and get the same answer. And so these are all different ways of doing that, is really what they are. Okay, so it looks like, fortunately, we actually had a fairly brief lesson today. Where we're going from here is the next lecture is going to take us into solving trig equations. And that takes a little bit more thinking. It's a little more touchy-feely. You know, there's a little bit of algebra. You have to know how to do things like factor and stuff like that. So if you need to go back to a previous video on factoring, not a terrible idea. But in any case, we're done here for today. So until next time, keep your pencils and your wits sharp.